Hello, everyone. Apparently, I caused a little bit of confusion when I did not elaborate on what the Driftless area in Wisconsin was. Well, I'm going to touch on it here a little bit. Those of you who have watched me for a little while now have seen me zoom in and you see all this stuff. Well, this stuff are stops that I've gone to that are going to be in the Driftless area book. Okay, but I'm going to show you some detailed maps and some figures I may or may not put in the book. I do that when I write roadside books. I'll make like a ton of figures and then I'll put like 2 or 3 in. So yeah, but Driftless area. What is the Driftless area? Well, actually there's 2. But we're going to talk mainly about the big guy up here. There's another one down here. And when I say Driftless area, I mean never glaciated. What do I mean by that? I mean the glaciers never rode across the area. They never sat upon that land. Now, that doesn't mean there's no glacial deposits. You have slackwater lakes and outwash channels and stuff like that. But the glaciers themselves never sat there. And I think people think it's weird because they know this has all pretty much been glaciated from here north and except this area. Well, let's talk about that a little bit. Here is the last glacial advance, Wisconsin, okay? And you can see, this is probably going to be in the book. You can see all the Laurentian ice sheet, the main sheet. This is where the ice was anywhere from 1 to 2 kilometers thick. The lobes were not that thick. The lobes were half that thick, if that, and the sublobes were maybe 100 meters. I know that may seem odd because you're taught from an early age, oh, the ice was a mile thick here. No, you do the math, and we know the rate at which these retreated now, and they just wouldn't have melted in time. So that means the glaciers were not that thick the further you got away from the main ice sheet there. And if you notice, if you ever know what isostatic rebound is, it's elastic deformation on top of the continent. Somebody pointed that out, and that was very good of them. And when the glaciers left, they're coming back up, but the hinge line, if you will, for that is somewhere in here, I believe. It's not a straight line, so it's near the Laurentian ice sheet. It's near the thick ice. This little ice, these lobes and sublobes, they didn't play that much of a part in depressing the landscape. Now, let's talk about what makes up a glacier a little bit here. Continental, like the ones that covered Canada and the U.S. This would be your Laurentia ice sheet. This is your main ice sheet. Now, this is not vertically to scale. We have meters here. Horizontally, I haven't decided what to put here yet, but you can just assume that maybe from here to here is 100 kilometers, okay? That's fine. Oh, wait, I do have it. I have the latitudes here. Man, sometimes I forget my own name. So I don't have a distance by the latitudes and comparable cities to those latitudes. Some of you may and may not know. And you can see the hinge line is real close to where the big ice sheet was. And this is curved. This does represent the curvature of the Earth, but the ice is depressed the crust here. And as the ice sheet moves forward, there's something I need to say. Glaciers do not act like bulldozers. They don't do that. They don't shove things in the front, because if they did that, eventually friction would stop them and they'd never make it anywhere. They erode by plucking and abrading. The ice actually, as the snow falls, the ice becomes heavier, the bottom becomes mobile, becomes plastic, okay? And sometimes it has enough heat to even melt. We have deposits, and you guys can look this up too. You'll see people walking under glaciers. That's because water has channeled it out. So the ice will wait and then it moves forward, okay? And as it does, it picks up material. And as that material gets incorporated, it gets finer and finer. And in some places, it gets dumped on top and may even grow a little forest if it's stagnant. Glaciers rarely stagnate. Even if they are forming a moraine and not advancing forward distance-wise, the internal ice is still moving forward. You have equilibrium. You have the advancement of the ice is the same rate as the melting of the ice. and that's how you get the end moraines. Okay, and glaciers can spend lots of time there. Equilibrium seems to be something they prefer. I'm not talking about them as if they're living, but just the physics state of it. So this is the cross section of a general continental glacier. You see Wisconsin's here, Oshkosh. Oshkosh was glaciated, I believe. Yeah. And then, Michigan, Champaign, Illinois, and then you get to Evansville, Indiana, which is never glaciated. Now, the glaciers themselves, let's talk about this. This is something I have for sale. I think it's on the Midwest Institute of Geosciences and Engineering website. If not, it's on Geodesics. This took me years and years to make. Now, I'm going to show you this a little bit, but not too much. All right? And what do you see here? The white is not just empty. All right? Now, you can see I stocked it at the U.S.-Canada border. Now, this is just for the mid-United States. You can see there's white here and white here. As far as we can tell, during the Quaternary, from 2.4 million years ago to today, ice never sat here or here. You look at these deposits, the reds and purples are Illinoisan, the greens are Wisconsin. Wisconsin is the most recent Wisconsin, and I don't think it matters at this point. People call them either or. Potato as far as I'm concerned anymore. I mean, I love stratigraphy, and I'm a big fan of the North American Stratigraphic Code, but that's just one of those things that annoys me. But Wisconsin would be the most recent. That would be from the, 75,000 or 50,000 years ago, depending on where you're at, to today. Okay? Now, the Illinoisan is from about 350,000 years ago to about 75,000 years ago. The browns, these are all pre-Illinoisan. There's a little bit here. Now, the stuff is under here too. There's Illinoisan under here. We do know that. There's actually is an outcrop of pre-Illinoisan under the Illinoisan here. So we know this ice lobe came in huge. As you can see, that is, we'll come back to that. The Wisconsin glaciers, see, this is that small driftless area. The Wisconsin glaciers never made it anywhere near as far as the pre-Illinoisan in Illinois. And now there's reasons for that, which I am not going to talk about here, but it just has to do with climate, okay? And for some reason, it's not showing the undermap, so it doesn't matter. Now, the driftless area is not just Wisconsin. Okay, so just remember the browns are pre-Illinoisan, the reds are Illinoisan, and the pinks and the purples, and the green is Wisconsin, okay? And here's the till correlations. Now, the way lithostratigraphy is we have the North American Stratigraphic Code. The first one came out in the 70s, which is kind of half-assed. And then the first official good one came out in the 80s, and about every generation we take another look at it. And it hasn't changed much from the 80s, but it's free online, North American Stratigraphic Code. The most recent one was 2020, maybe it was 2021 there were updates. Maybe it's 2005. I forget. Anyway, this wasn't supposed to be a stratigraphy talk. Sorry about that. I forget things. So you can see that, like here, these two units, even though they're mapped as different names, they're likely the same formation. And you can see some stuff ends here. That's because the Illinoisan stratigraphy in Illinois, which this is, has not been redefined. Somebody was working on that a while ago, and I don't know what happened to it. But the Wisconsin and Illinois, the gold standards for lithostratigraphy in glacial deposits is Illinois. It's Hansel and Ardith, 1991, and another gold standard is there's another Minnesota. Wisconsin's really good too. The people that suck at glacial stratigraphy, and this is true, I'm just going to say it. I'm calling it as it is what it is Ohio sucks, but they're better than Indiana. Indiana really sucks. Missouri's horrible. And Iowa also sucks. Iowa's real good at this Wisconsin age lobe right here. But when it comes to the pre-Illinoisan stuff, No one's bothered with it. They divided it into a couple formations. I have yet to see a map that delineates it. They don't tell you where the limits are. Nothing. So these are estimates where these borders are. Okay. So anyway, let's get back to this. Let's see the Driftless area. You can see here, hopefully you saw that. This is Illinois. You can see this clear as day. The north half Illinois. Chicago's right here, okay? And then this area, all right? This is the Galena area. This is the only driftless part in Illinois other than that low part that we're not going to talk about. And you can see, this is how I'm dividing it for the book. You're looking at it right here, all right? Now, here's the thing. What exactly is driftless? Now, you look here, even at this scale, you can see, come on, Minnesota, I got to give it a minute. This map is actually massive. I'm surprised my little crappy computer can even halfway deal with it, quite honestly. So oh no, we don't need to go out. Go back in. Okay. Now, these are lithostratigraphic units. You see I is Illinoisan, W is Wisconsin, P is pre-Illinoisan. Now, pre-Illinoisan covers basically from 2.4 million years ago to, what is it, 350,000, something like that. Because it's hard to differentiate the ages of these, because carbon dating at that point is pretty much moot. There's, this stuff's all got chunks of wood in it and stuff we can directly date. So they're kind of in this really weird area, but they have been dated, a couple of them. Anyway, you can see these tongues here. This doesn't mean we had tiny little sheaves of ice sticking out. This unit likely was bigger. This purple likely came out and was bigger. So the driftless area is not entirely driftless, if you will. We don't even agree on where these boundaries are. I basically define the driftless area as where glaciers never stood, as far as we know, or the evidence of them is patchy. Like, did I get rid of it? Oh, I think I did. Up in Minnesota, you might have, or wherever, like you see, they're connected here. So it's part of the glacial deposits. Now, there are glacial deposits here and there are tills here. It's just, we don't really bother. Wausau's up here somewhere, okay? So I include it in the driftless area just because nothing's continuous. Like, you'll have little potted outliers here. If you want to talk about where there's absolutely no evidence of ice, it's this yellowish, oh my God, it's this yellowish and this greenish area here, okay? This I call the sub-driftless area. This is where, and I actually pushed it out a little bit, the maximum extent of where we think they were, the glaciers. This is a cluster. The glaciers probably did sit here, but we don't know because it's all outwash deposits. There's no known glacial deposits here. It could have been driftless, but probably wasn't. This here is ancient glacial Lake Wisconsin, right here. And this is the front of the Wisconsin glaciers, okay? So this area and this area were truly driftless. And so that's Wisconsin. Here's the Mississippi River up here. So you have Iowa. You can kind of see the top border here. So this is Minnesota from here. That's Illinois. You can see this is Iowa there, and it stops right there. So that's the driftless area. And you can tell by the topography, and you can tell I have a line here, but you may even be able to see this. This was something I thought I just discovered, but apparently it's already been named. So I had to change all the language in my book, and I'm glad I found it. I happened to stumble upon it. This is called the Centipede Ridge. Part of it's called Military Ridge. And Madison, Wisconsin's right over here. So Madison's right at the edge, but it does sit in the glacial area. Baraboo, Wisconsin's up here. As a matter of fact, Devil's Lake is right here. You see where my cursor is? Devil's Lake sits right at the edge of the driftless area. The lake itself is in the driftless area, but you stand upon the eastern bluff at Devil's Lake, and you can look, or the western bluff, sorry, look across to the east and you can see this end moraine here. The Johnstown, I believe it's called, end moraine. All right, so that is clear as day. There are places where the driftless area, the border is clear as day. That's one of them. Then you get more ambiguous ones like here. Like I was driving this way and I made a video, but I never posted it. When I was going from glaciated here, and I'll tell you why in a second, to unglaciated here, but on the lake bed. Now, this is very flat and uniform, and this is only slightly less flat. And this stuff right here is borderline outwash. But the topography didn't change as drastically as it does like down here. I mean, down here, the border between the driftless area and what had glacial ice on it is clear as day. It's like night and day. You're driving this way to 20 to Galena, and you'll see where all the flat cornfields end, and all of a sudden you got these massive hills. Let's see, same thing in this area of Wisconsin, same thing over here in Minnesota and in Iowa, that kind of stuff. I did include Decorah, Iowa. That's somewhere over here within the driftless area. Okay, and unquestionably, I sat there at one point, but it's patchy if at best. So the driftless area, the truly never ever glaciated, is this green part, which looks like the outside green. I got to change that, and this yellow part here. And that's ever. Oh, did I just close it? Steve, you suck. So you can see here, here's the Mississippi. Oh, by the way, the Mississippi River, you see Illinois here? Mississippi River up until the Wisconsin, even though the Illinois ice sheets covered it at one point, and so did the pre-Illinois into at least here, and it reestablished its course, the Wisconsin glaciers somehow shoved it west. It used to come down this way, connect to the Illinois River, and come this way. This was the ancient Iowa River. There was no river here. Okay? When the Illinois glaciers came through, they pushed it west, and then it reestablished itself back here once the ice melted. Same thing with the pre-Illinois, and it moved it over, well, it was already here, so it really didn't have to move anywhere. Okay? But the Wisconsin glaciers came, the green here, and they cut it off. Why? Well, because of the outwash. There was a unique situation in this area, and it confused geologists for a while. Now, this is just the till units. This isn't outwash or lacustrine lake deposits. These are just glacial till deposits. That means this is where the glaciers park their butts. Okay? And in the Wisconsin here, we thought these two units were Wisconsin for a while. All right, and this. But they're Illinoisan. We know that now because of dating. But what sits upon them and cuts them is this massive sheet of outwash that just blew west. Now, we're not sure exactly. It's not the Kankakee turret. The Kankakee turret is over here. Started up here, blew this way, and came down this way through Illinois. Okay, that's the Kankakee turret, and there were glacial lakes here on the Yorkville and stuff like that. This is the shore Lake Michigan. Okay, so for some reason we had massive discharge here, and so we don't know why. I don't think anyone's really studied it, but that was enough to plug this river. When it came over, the Mississippi used to go this way. It just plugged it. And the Mississippi could not reestablish itself. So it moved permanently west. Okay? And we can tell that from the channels. And like I said, here's another little driftless area. Down here isn't driftless because it's technically the edge of the glaciers. The glaciers never went further south than this. That doesn't mean it wasn't colder to the south. That just means the glaciers never reached past that. All right, but there is some evidence in southern Illinois that there might have been a couple here, so this might actually extend a little bit. All right, so the driftless area, why is it there? Why is this little area here? Now we got to come out and zoom out a little bit, and this is where geology controls flowing objects, whether it's ice or water or wind, whatever. I really probably need to get that other thing back up. Where is that ice sheet? Brother. Like time scale. Yeah, see, there's a lot of stuff here. Magnetic reverse. This is oh yeah, this is another river that the glaciers totally plugged. Okay, this was the second largest river system east, or no, it was the largest east of the Mississippi. Okay, and it's gone. A part of the Wabash River, which comes down this way now, comes down here and connects to the Ohio River, that is re-exposed, a tiny bit of it. That's what that little bit is. But here it's completely buried. And this is the old Mississippi River channel that no longer goes there. So you use the ancient Iowa River, ancient Mississippi or ancestral. Sometimes they call them ancient. Sometimes they call them ancestral. I don't name these things, But let's go to, I want to get that dang map back. Cover relief map, ice cross section, magnetic. Oh yeah, direction. Okay. You see how this is? This is messy. And how do we know this? Well, we know this from two main things: eskers and striations. Glacial striations are linear, parallel, straight lines grooved into the bedrock. And we know the ice didn't flow from south to north. Generally came from north to south. As you can see, there's a couple places it came west and almost banked north, but this stopped it. Okay? And you see lobes covering other lobes. That's because this lobe didn't exist until this lobe retreated. Okay? It's messy a little bit. So we try to keep it as simple as we can, but sometimes we can't avoid it. So you see the red areas are the directions, general directions of the ice sheets during the Wisconsin. So from that 75,000 years ago to, 10,000 years ago or 9,000. Yes, Jorgensen, I know. But you might be like, well, this is weird pattern. And it is, because you usually think of the Midwest as being pretty flat and level. But pretty much everything that has glaciers on it pretty much resembled before glaciers, like the Driftless area. And this area does, again, the UP up here, all right? It looks a lot, except the eastern half. So, and up here too, there's not a lot of existing ice deposits, because once these lobes started to melt from like they pushed the advanced up to their max, so maybe 25,000 years ago. Then they retreated about 13,000, hung around for a while, little pulses, whatever. But between 13,000 and 25,000 years ago, they did this. And then when 13,000 years ago hit to maybe 12, the retreat was, it just bam. So by 8,000, 7,000 years ago, the ice sheets are pretty much where they are today. And then they stopped again as they got further north. And quite frankly, today is the smallest we think the ice sheets have ever been. Up on Greenland and Baffin Island and the Arctic, okay? But anyway, what's here? The Great Lakes. Well, the Great Lakes did not exist during the Ice Age. Now, they may have been scoured out previously, but they seem to have been river systems that would get gouged out deeper, and they never established lakes except Lake Superior. Lake Superior seems to have restored itself to lake status whenever the Ice Ages retreated, and was probably there before the Ice Ages started. It has to do with the Mid-Continent Rift and all that stuff, which actually is the reason, the Mid-Continent Rift is the reason the Superior Lobe goes like this. So where Lake Superior is now, okay? And as you can see, it had a hard time breaking south. So it wanted to move west and follow that rift valley, because it was easier to cut out these sandstones that sit upon the Portage Lake volcanics than it was this hard Archean and Proterozoic rock that's here, okay? But it did get over it a little bit, but that's as far as they got during the Wisconsin. Over here, if you remember the pre-Illinoisan, here, Let me zoom out a bit and see a little better. It's the same base map. I did the county maps. It took me forever to do. You can see this lobe came down here in the pre-Illinoisan. In the Illinoisan, it doesn't seem to have done that. The ice seems to be restricted to this half. I don't know why that is, but there's, or to this half with a little bit like up to here. This never re-advanced. I don't know why. But anyway, the pre-Illinoisan, it came down this way. Why? Because geology is real easy to cut forth here. And what do you have over here? You have the deposits of the Western Interior Seaway, Cretaceous rocks, Tertiary rocks, stuff that's unconsolidated. So the glaciers could push much further south, okay, in the pre-Illinoisan, all right? And the pre-Illinoisan did get into Illinois. There are some subsurface ones, but it seems to have gotten no further than maybe a little bit further south of Lake Michigan, okay? But because there was bedrock under Illinois here, you don't get into loose, unconsolidated stuff till you get the Pennsylvanian in the East Interior or Illinois Basin down here. That's why they did make it a little further, okay? But you see the Wisconsin doesn't make it as far. I think I mentioned that already. But they tend to go back in the same places that if they could have. You see this Wisconsin lobe, age lobe, followed the pre-Illinoisan age lobe. The Wisconsin here followed the Illinoisan down here. All right? That's because this was already established. But what's special? What's special about here? What is so special about this area right here? Oh, that was glaciated, but like right here. Quite honestly, not much. The reasons are numerous. Likely one cause didn't do this. We used to just think it was, higher out in elevation, so it just didn't get overridden. But that doesn't work, because some areas further south were higher in elevation and got mauled over by the glaciers. Things at the same latitude in places are at the same elevation and got glaciated, and things up here are at the same elevation and got glaciated. So that might have played a part, but it wasn't the whole part, okay? Another reason is probably the Mississippi. The Mississippi rivers, even big ones like the Mississippi, do not exist forever. They're actually short-lived things. The Mississippi River it's older than the ice ages, okay? It's definitely older than that. But it would still flow. Now, you might sit there and think, this was all just frozen wasteland here. It wasn't. The glaciers get to us, so you have to think, this is like, 37 degrees south, or right here, about as far as the glaciers ever got, okay, in the pre-Illinoisan. That's pretty far south. And the temperature here would not have been minus 70 degrees, ever, okay? You would have had, in this area, the southern limits, you would have had summers where we hit 80, 90, even 100 degrees, but it wouldn't stay that way, okay? So that's part of the reason. Glaciers, once they hit a certain latitude, just weren't going to go any further because of the climate. Okay, so that's another thing. So we have the Mississippi going through here, so we get melting here. And a lot of these glaciers, like I said, they melt at the bottom, and they get lubricated at the bottom. Well, here the geology is a little different than it is elsewhere. We have level Precambrian Ordovician sandstone aquifers, okay, which would have taken a lot of that water a lot easier. Now let's go to the book here. I think I give the actual explanations. Can't believe I'm showing you the inside of my book. What is wrong with me? Let's open this. Okay, introduction. I'm scrolling through this because a lot of this needs to be changed. Why would I say the mechanics gun? I've talked about that. Frozen, tundra. There's tundra evidence. Why were there even ice ages? Are there any other driftless areas? The little one. Advances, minor glacial advances. I don't think I get into it in this section. Yeah, I don't. Okay. So, I don't. I haven't added that part yet. It's written somewhere else. So we have Our factors are the Mississippi River. I really wish it would keep the borders. I don't know why it does this. All right. So we have the Mississippi River. We have these Cambrian, Ordovician, relatively flat-lying Cambrian, Ordovician aquifers, which are pretty much all sand in this area. They're not as you go further south. They become carbonates, right? You know, you might hear young Earth creationists saying, oh yeah, during the Cambrian, the Earth was covered in sand. That's complete BS. Most of the Cambrian deposits are carbonates. It's called the Great American Carbonate Shelf for a reason. It's not because it's sandstone, but in this area it is. And you have a structure here called the Wisconsin Archer Dome, where it does get pretty high here, okay? So the ice would have been directed to follow the valleys of previous glaciers. They're going to follow the path of least resistance. What's more easily eroded, you know, the Mid-Continent Rift sediments, these Cretaceous Tertiary sediments, you know, the Michigan Basin sediments did have a little problem getting over the Niagara escarpment, which goes from basically here all the way down, cuts across Ontario, goes to the Niagara Falls. But it wasn't that pronounced during pre-glacial times for it not to be able to go over it. And then you get here, you can see this is where the East Interior Basin is. That's mostly Pennsylvanian shales. So of course, once the ice hit those areas, it was able to go, except during the Wisconsin. Why didn't the ice go further? Are we at the end of ice ages? Is it because it just got warmer faster? No. Actually, the Wisconsin advancement of ice sheets, 75,000 years ago to about 10 or 9, whoever you ask, it doesn't matter, was the coldest period. And what happens when ice gets really cold? It becomes rigid like rock. It doesn't flow as easily. And that's why it didn't get as far south. When the pre-Illinoian was going on, the ice was warm. And it was very plastic, and it would just go as far as it could until temperatures and climate wouldn't allow it to go any further. All right. So, are we going to have another advancement of ice sheets? I don't know. I think we will. You know, because, you know, humans are messing with climate. It's becoming warmer faster. And eventually, it's going to put us in our place. Will we go extinct? No, we're not. Not from this, okay? But we will be great. We will be kicked in the teeth hard and knocked out for a while, okay? So when that happens, the climate will start to go back to normal. It'll take a while, but I think we got one more in us. But I don't think the ice is going to go south of Lake Superior that far, if it even does. It might even stay in Canada. Because this is the largest Lake Superior has ever been, even if it existed 80,000 years ago. And it probably did. It wouldn't have been this big. Because those last ice sheets of the Wisconsin, they were colder, okay? They were more brittle, and that allowed for a deepening of this that wasn't done before. And they were thicker. Even though this isn't that thick, they're thicker than they were the other times, except your sublobes might have been longer, okay? But I think that's it. Anyway, if you have any questions or comments, please leave them below, and I hope you guys learned something.